In today's video, I'm going to show you how you can make Ben Heckendorn's gameBadge. That's the Pico-based wearable video game system that you can take with you and play My Tetris Clone or whatever other game you put on here on the go. This year, my son Lincoln and I headed out to Milwaukee to attend Midwest Gaming Classic 2023. Now, this was the second year that we attended MGC, and even though we're not native to Milwaukee, we had such a good time last year and just had to come back. Our flight arrived late Thursday night, so we checked in at the Hyatt and caught a couple episodes of BattleBots on the hotel TV before heading to bed. The next morning, we headed over to the Hilton to help Ben Heckendorn with his gameBadge workshops. We ran 2 workshops, and they were both packed full. As expected, Murphy's Law wasn't going to let us down though. We did have a couple of hiccups throughout the day, such as running out of tack switches. However, we overcame those, and despite all of that, the workshop went great. Everyone walked away with a fully functional gameBadge. The next morning, Lincoln and I woke up, had some breakfast, and walked over to the convention center. One interesting thing is that there's an indoor walkway that takes you about 80% of the way there from the Hyatt. Now this is really nice because there was a bit of rain over the weekend. When we arrived, we walked around for a bit just to get an idea of how everything was laid out. I could definitely tell that there were more people there this year, but it still didn't feel too crowded, or at least not in the morning. As the day picked up though, it did seem to get a bit more packed. One of my favorite parts of MGC is the large arcade and pinball room. Now this room is set up with dozens of arcade and pinball machines all set to free play. We spent a lot of time in here, and in keeping with last year's tradition, we picked a couple of arcade games and played them all the way through. We also spent a bit of time in the marketplace area, seeing what kind of interesting things people were selling. A lot of the sellers had really jacked up the prices on some of their items though. I guess the expectation is that you're going to pay cash and bargain with the sellers to bring down the price. Now I was a little bit smarter this year and brought a shopping list with me, which I didn't do last year. I did some research on each item that I wanted ahead of time and wrote down the maximum price that I was willing to pay. And this helped me a ton with making good judgment calls in the heat of the moment when I was bargaining with sellers. Speaking of which, I did manage to find a couple of things that I'd been wanting, such as a Neo Geo Pocket Color and a couple of Master System games that I'd been in the market for. Overall, MGC was a great time this year. Lincoln and I had a ton of fun together, and it's just nice to get away for our father and son trip and have a nice little guys weekend together. But I do have to say that my favorite part of the weekend was the gameBadge workshop. Now, if you're not familiar with it, the gameBadge is something that Ben Heck specifically designed for MGC. You could probably say that it started at MGC 2020 when Ben created the Z80 Note Badge. Or at least it would have started at MGC 2020 if the event hadn't been canceled because of, well, you know. The Z80 Note wasn't specifically designed to play games. Ben created it as a single board computer that you could program in BASIC and wear around your neck like a conference badge. Now I haven't built one myself, but it's a neat project and definitely on my list to do someday. The first version of the badge that was dedicated to playing games was designed by Ben for a workshop at MGC 2021. Instead of the Z80 CPU, he used an AT-Tiny microcontroller and shrunk down the overall board a bit. Then for MGC 2022, Ben largely kept the same design, but made a few tweaks. Now I had intended to catch the workshop that year, but ended up arriving late to Milwaukee, so Ben was nice enough to spend some time with me afterwards to take me through the build. And over the past year, the gameBadge has been sitting out on my desk, and I've been getting in the occasional game of Moonforce when I need a mental break. But that was probably the last year for the Atmel-based badge, since the ongoing chip shortages have made them harder to find. But one MCU that's been abundantly available is the RP2040, which is in the Raspberry Pi Pico. So Ben made this next version of the gameBadge to run on a Pico. Aside from the much faster MCU, Ben also used a color LCD and did away with the piezo buzzer in favor of a speaker. When I started working with Ben on testing the badge and writing a game or two for it, I suggested that maybe he'd want to leverage some of these additional PWM pins to do multi-channel audio, sort of like the NES. So the gameBadge3 has 5 audio channels. Why so many, you ask? Well, one channel is used for playing WAV file audio, and the remaining 4 are used as waveform generators. All right, we've talked about it enough, so let's get into building one. Before we start building a game badge, we need to get our parts together. You'll find a complete parts list in the GitHub repo under the PCB folder. I'll talk about each of these parts as we go through the build process. Before jumping in, you're also going to want to grab a copy of the repo and put it on your computer. All right, the first thing to do is to get a PCB. Now you can order these from any PCB maker online, but I personally prefer JLC PCB. The quality is good, they tend to have the best prices, and my order typically arrives in about a week. When putting in your order, you just need to grab the Gerber files from the repo and upload them to the site that you're buying it from. Okay, so you have all your parts along with your PCB and a Pico. So we can now go ahead and get into the assembly process. Now you've probably heard this before, but I think it's worth repeating. Usually when you're building a board like this, the easiest way to do this is to start with the shortest components first and then build up to the taller ones. So that's exactly what we're going to do here. I'd like to start off by putting on the LiPo charger. This chip will manage the charging circuit for the battery. Now if you're not used to soldering surface mount components by hand, don't worry, it's actually quite easy. All you need to do is tin one of the pads and slide the component on with the tweezers. After it's lined up, just solder on the other pads. The LiPo charger is a bit small, so double check it to make sure you didn't bridge any of the pins. Next, you add a few different values of surface mount resistors. Now, when buying these, make sure to get them in an 0805 package. They're still small, but that size is totally workable with tweezers and a soldering iron. These here are 2 kilo ohm resistors. There's 4 of these in total. And there's 3 20 kilo ohm resistors that go here. And 4 33 kilo ohm resistors, which are used for balancing out the audio channels. And along those same lines, you also need 9 1 microfarad capacitors. Like the resistors, these should be surface mount in the 0805 package. Next is the voltage regulator. This will make sure the gameBadge gets a steady 3.3 volts from the battery when it's not plugged into USB. Solder in place one of the smaller pins first to line it up, and then do the others. This 8-pin chip here is the audio amplifier. As I mentioned earlier, the gameBadge3 actually has 5 audio channels. These 5 channels are summed together and fed into the input of this amp. Now, before soldering down the first leg of this chip, make sure you line up the dot with the marking on the board. We had a couple people in the workshop that put this chip on upside down. It's an easy mistake to make. Okay, the small stuff is out of the way, so you can now tackle the picot. The easiest way to do this is to stick it on with some double-sided tape before you start soldering it. This will help you line up the castellated pins and keep them in place. You want to make sure there's solder between each pin and the pad underneath it. The way I like to do this is to put my iron on top of the pin on the picot and then feed the solder into the crook where the pin meets the pad. Use a good amount of solder here, but be careful not to cause any bridges. Now it's time for some buttons. There are 10 in total, 1 on the back and 9 in the front. Now you can use any old tack switches here, but I'd highly recommend getting some switches with a lower actuation force for the D-pad and the A, B, and C buttons. It sounds trivial, but it makes a huge difference when you're playing a game on a smaller, lighter weight device like this. Now for mine here, I'm using tack switches with a rating of 100 GF, that's grams of force, for the controller buttons, and using cheap switches with a much higher actuation rating for the start, select, and reset buttons. Next, you can put on the LEDs. 2 3mm LEDs is all you need, and it doesn't really matter what colors you choose, that's up to you. The top LED is the power indicator, so I like to use red for that one. And the one underneath it is the charging light. Do pay attention to the orientation of the legs. The longer leg should be connected to the positive pin. Now for the power switch. You can put this on either the top or the bottom of the board, but if you do put it on the bottom, the case won't fit properly, so I recommend putting it on top. Now it's time to mount the screen. The screen's a little tricky as it requires some modification and a 3D printed bracket. First, you're going to want to take some flush cutters and snip away this plastic connector. You don't need it, and it makes the screen stick out from the board a little too far. The technique I like to use here is to snip each of the middle pins and then gently pry the connector up, so you can then slip in your cutters and cut the larger pins on the side. Now it's fine to leave it like this, but the other thing you might want to do is just take your iron and wipe away the chunks of cut pins and excess solder. Next, you want to take the header and solder it onto the screen with the short side of the header pointing up. Now if you want the screen to sit flush with the board, you'll need to 3D print this bracket and 4 pins. The STL files for this are in the GitHub. If you don't have access to a 3D printer, you can mount the screen using the 4 standoffs that came with it. But the downside is that the screen will stick out from the board quite a bit and just doesn't look as nice. The bracket sits between the PCB and the screen. Now notice the orientation of the bracket here. There's a notch at the top that fits around the voltage regulator, and there are grooves on the underside to bridge over the resistors. Just sandwich it all together and solder the pins in place under the board. Okay, almost done. The only things left are the speaker and the battery. I'm using a 1-watt speaker that I picked up from Amazon. For the battery, I like to clip and solder one wire at a time, just to make sure I don't accidentally short them out in the process. Alright, you have a decision to make. Before moving forward, you need to decide, do you want button covers? Because if you do, you need to install them now before gluing on the battery. They're not required, and some people actually prefer not to have them. Personally, I do like them, so I'm going to put them on. If you decide to leave them off, though, you can skip this step. For the A, B, and C buttons, you put the button cover on top, and then there's these pins that slide up from under the board. You can then use your iron to melt them into place. The D-pad comes in 3 pieces. You'll need to glue the piece that looks like a crosshair onto the flat side of the circular piece. The easiest way to do this is to use the square peg to line it up and keep it in place while the glue dries. The grooves on the underside of the circular piece sit on top of the switches on the board, and the whole thing attaches to the board from a screw underneath. Now this is a nice design because you can adjust the screw to set the tension of the D-pad to whatever you prefer. Now I don't know what the size of the screw is that I'm using here. It's just one of the leftover screws that came with the screen. And once that's done, you can go ahead and hot glue the battery on. There is nothing real scientific about this, just plop it on under the Pico. For the speaker, I just hot glued it to the inside of the back case at a spot where it would be out of the way. Speaking of which, the STL file for this case is also in the GitHub, so you can print one of these too if you want. And if you don't want a case on it, you can hot glue the speaker to the board directly. The hardware's done now, and it looks great. So let's plug it into the computer to charge up the battery and load the firmware. Start off by plugging the USB cable into the gameBadge. And then hold down the boot select button while you turn it on. The process of loading up the firmware is pretty simple. Because you held down the boot select button, the gameBadge will appear as an external USB flash drive. All you need to do is drag and drop this UF2 file into the drive. Give it a moment to reconnect, and then hold down the boot select button again and press the reset button. The gameBadge should reconnect to the computer into UF2 mode again. Next, you'll want to load up one of the games. Now there's 2 games in the GitHub repo right now. There's Ben's game, which is called Catsylvania, and then there's the game that I wrote, which is a Tetris clone that I called Badgerous. Now Ben's game is fun, but I'm a little partial to Badgerous. Loading up a game is a 2-step process. First, drag and drop the UF2 file for the game over to the flash drive when the gameBadge is booted up into UF2 mode. The gameBadge will then reboot, and it'll reconnect to your computer as a standard USB flash drive. Then you'll need to drag and drop the game assets over to the drive. For Badgerous, you can just copy over the entire Badgerous folder. Okay, that's it. Time to turn it on and try it out. And here's Badgerous. I wrote this game over a period of 3 to 4 weeks using VS Code with the Arduino extension. For the graphics, I used YYCHR. This is an editor that Ben mentioned in one of his earlier gameBadge3 videos. And for laying out the screens, I used a map editor called Tiled. I've used Tiled for other projects in the past. It makes this whole process much easier, especially for games with tiled graphics. And the result of all this is a game that closely mimics the NES version of Tetris. The screen on the gameBadge uses double-wide pixels, so the effective resolution is 120 by 120. Because of this, I couldn't make a pixel-accurate Tetris clone, so I did my best in arranging the screens to include the most important elements of the game. The music and sound effects should be familiar. Since the gameBadge has multi-channel audio, I ported over a waveform generator library to play different types of waveforms on each audio channel, very similar to how the NES does it. Alright, that brings us to the end of another episode. I hope you enjoyed exploring the gameBadge3 with me today. Now, if you want to build your own, the schematics and the parts list are in the GitHub repo. The link's in the description below. Well, I really enjoyed making this video today, and I hope you enjoyed watching it. So, until next time, go make something cool.